Assalamualaikum and good day to everyone. I am Dr. Aisha from UTHM and I'm going to cover a topic in the subject of enzyme technology, which is the preparation of commercial industrial enzymes. I will cover only a part of this topic, and the rest of the topics will be in the other lecture videos. So this is a introductory lecture slide. So we know that commercial enzyme preparation are different from enzymes prepared for research purposes. So why do we say this? Because the aim is different. For research purposes, we would like to have a very high quality enzyme that has been purified in several steps and it have a very high specific activity. Whereas commercial enzymes, the aim is to produce in huge quantities in bulk production, and you want it to be functioning, but it doesn't need to be highly pure. So it's different. So you need to know what is your aim first, whether it's for research or for commercial industrial distribution. Okay, so enzyme for research purposes need to be at the highest possible purity, and due to that we need to perform several purification stages, and due to the purification steps you can have a lower enzyme yield. Okay, so we will look at this table here. So this table is good to elaborate on the effect on the number of purification steps on the yield and the cost for a typical enzyme purification process. Okay, so if you can see at the first row here, you have 100% yield of enzyme. So why is that? Because there's no purification steps. However, because there's no purification step, you only have very little specific enzyme activity. So here it indicates only 1% specific enzyme activity. So in order for you to get either enzyme for research purposes or for industrial use, you need to have some sort of purification. Okay, so here you can see if we use increasing number of purification step, you will have lower yield along the purification step. However, you have higher specific enzyme activity if you have more purification stages. The cost will be increased as well as the number of purification steps increase. Okay, so that's the most important part of this table. So you need to deliberate on the most optimal purification step that you can get away with for a commercial enzyme. Okay, so it differs from enzyme purified and prepared for research purposes. So for commercial industrial enzyme preparation, you will want to get away with the purification step as little as possible at a purification step. So most likely we will only remove material that can interfere with the catalytic function of the enzyme, and other unnecessary purification will be avoided due to, for the most part, the cost as well as the loss of enzyme activity. Because we want to have higher yield and lower cost, you need to consider the loss of enzyme activity factors. Okay, so as a result, most or some commercial enzyme preparation will consist of fermentation broth plus additives to stabilize the enzyme activity. So we will cover a bit about additives in the other coming lectures. So in commercial enzyme preparation, you would want to have at the starting point or at the upstream point high enzyme content. So when you have a high enzyme content in the upstream processes, so in the downstream processing, you will have cell disruption. To disintegrate the cell, you will have liquid-solid separation as well. So these purification stages will reduce the enzyme content. Okay, so to have a high enzyme content at the upstream processing stage, you can use these two methods. One is to optimize the fermentation condition. So you can do this by optimizing the medium that you use, the inoculum ratio, and another method is by genetic engineering. So we can manipulate overexpression of your enzyme within that bacterial host, for example, in order for you to have higher enzyme content produced in these stages. So we won't be covering this as much in this subject, but I'm sure it will be covered in other subject in your course. Yeah. So moving on to the next slide, we want to look at the factors that can inactivate enzyme activity. So why is this important? Because you want to retain the enzyme activity during the enzyme preparation so that you can have a product that have a determined amount of enzyme activity. All right, so you need to have a reliable enzyme activity. So we want to avoid all these factors. So what are those? Those are heat, proteolysis, suboptimal pH, oxidation, denaturants, irreversible inhibitors, and loss of cofactors or coenzyme. Okay, so let's look at it one by one. So I know that we have covered this before, a little bit of it in the previous lectures, but we will touch on it a little bit here as well. So if you remember, heat is an important factor in pH as well. So together they can affect the enzyme activity up to the stage of inactivation. So it is also affect non-thermophilic enzyme rather than the thermophilic enzyme. So you need to have a good cooling processes during the downstream processing. Okay, so proteolysis can also happen, especially in the first stages of extraction and purification, because they are still present. Proteases are still present in the cells, and if you have contamination as well, then you can get proteases attacking your protein, and it can also be because of the heat factor and the pH factor again. If those factors affect the conformation of the protein, so if the proteins are like this in 3D conformation due to less than optimal heat and pH, it can have a different conformation, stability, and proteases will be able to attack those sites that are vulnerable, and when you have nicks within the enzyme, then it can get unfolded and get destroyed. Okay, too many doodling here, sorry about that. Next factors is the oxidation. So oxidation is caused by oxidative enzymes, so it can inactivate an enzyme, another enzyme. Denaturants, it can be heat or chemical one, and if it can denature protein, then your enzyme is inactivated. Irreversible inhibitors, so if you have another molecule that is competitively going to your to the enzyme's active site, then it can bind to it and it can irreversibly inhibit the enzyme, and thus you will not have the activity. Okay, the last one will be your cofactors or coenzyme. So as you know, cofactors are a non-protein compound that help the enzyme to perform its catalytic activity. Okay, so one example of cofactors is NADH. So if you have a loss of cofactors from the enzyme solution, then it will affect the enzyme activity and thereby inactivating it. Okay, so the last slide is to show the flow diagram for the preparation of commercial industrial enzyme. Okay, so pardon me. So you can have three sources of your enzymes. So most are from microbial fermentation, but you can also have other sources, for example plant cells, animal organs, or plant latex here. So from this preparation, you can get your enzymes, whether it's intracellular or extracellular. So to remove the biomass at the initial stage, you will need to use a liquid solid separation method. So this can be centrifugation method or filtration method or biphasic separation technique. Okay, biphasic partition technique. pardon me, biphasic partition. Okay, and after you have separated the biomass from the liquid, then you will also perform cell lysis, cell breakage, or cell disintegration here, where the cell is lysed, and then you will need to perform another liquid solid separation technique. And then if the enzyme is in the liquid, you will remove the solid, put it in the bin, and then you will perform removal of nucleic acid and a purification stage, and you will have concentration step as well as the polishing before you get your final product. Okay, so we will cover in a lot more detail on the liquid solid separation technique within this enzyme preparation context. Okay, so we will cover that in the other lectures. So this is my reference for this video. Thank you for listening.